Welcome to Educator.com. In a previous lesson, we talked about solving quadratic equations by graphing, and we're going to go on to discuss another technique, an algebraic technique, which is solving quadratic equations by factoring. So, first starting out with just a brief review of the different factoring techniques. And each of these are covered in depth in the Algebra 1 series. So if you're unsure on any of these, make sure you review that before you go on, because we're just using these techniques as a tool now to actually solve quadratic equations. Okay, first remember the greatest common factor. And the greatest common factor of two or more numbers is the product of their common prime factors. So the GCF of two numbers is, or two or more numbers, is the product of their common prime factors. And in factoring, often when you're factoring an equation, if there is a GCF, you want to factor that out first, because then you're working with something less complicated. For example, if you had 4x squared plus 16x plus 36, you'll recognize that there is a GCF of 4. So I'm going to factor that out and get 4 times x squared plus 4x plus 9. So factoring out the 4 gives me x squared plus 4x plus 9, and this is much easier to work with. So remember to factor out the GCF first, if there is one. Recall the difference of two squares. You'll recognize this because it's going to be in the form a squared minus b squared. So an example would be x squared minus 4. And that is equal to x plus 2, x minus 2. So this is the difference of two squares. Here's plus and the minus. And so when you're factoring, if you recognize this, you can quickly factor it as the difference of two squares, knowing that it fits into this formula, a squared minus b squared. Perfect square trinomials. Perfect square trinomials would be the result of squaring a binomial. For example, if you have x squared plus 6x plus 9, this is actually equal to x plus 3 squared. So if you take a binomial and square it, you'll get a perfect square trinomial. So take a binomial, multiply it times itself, that's what a perfect square trinomial is. And so recognizing that makes for easy factoring. General trinomials are a little more complex to factor. Again, you can review all of this in Algebra 1, techniques for factoring. And an example of a general trinomial would be x squared plus x minus 12. It doesn't fit into any of these special cases like the difference of two squares or perfect square trinomials. So I have to do a little more work in factoring that out. Recall from earlier lessons that you need to look at the signs. I have a positive sign here, I have a negative here. And if I have a negative, that must be the result of multiplying a positive and a negative. I then look at what the factors of 12 are. And the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And I need to and one will be positive and one will be negative. And I need to have factors that sum to this middle term, which is actually 1. And I can try different combinations. And I know that negative 1 and 12 is not going to work. Negative 12 and 1 certainly won't work. And I go on down. And from that, you can see that if I want them to sum to 1, I'm going to need factors that are close to each other. And the closest two I have here are 3 and 4. So if I make 4 positive and 3 negative, then when I add the outer term and the inner terms, I'll get my middle term x. And you can always check this using the FOIL method. First terms, that's x squared. Outer terms, negative 3x. Inner terms, 4x. And then the last is negative 12. Simplifying this, I get my original back. So general trinomials take a little more work, and you can always check those by multiplying it back out to make sure you did it correctly. So making sure you have all these, know how to use them well, and then we're going to be using them today to actually solve some quadratic equations. Now, once you've factored, you need to use the zero product rule to actually find the solutions. And what the zero product rule says that for any number a and b, if ab is 0, then either a is 0 or b is 0. Because if a equals 0, then you'd get 0 times b. That would work as a solution. If b is 0, then 0 times a would give you 0, and that is also a solution. For example, if I was given x squared minus 16 equals 0 and asked to solve that, I would first recognize that it's in the form a squared minus b squared, and that it is therefore the difference of two squares. That allows me to factor it pretty quickly into x plus 4, x minus 4. So I factor in this, and it still equals 0. Now, use the zero product rule. The zero product rule tells me that if this is 0 or this is 0, then this entire thing will equal 0, which is what I want. So if x plus 4 equals 0, this will be solved. If x minus 4 equals 0, this will be solved. So I'm going to set this factor equal to 0 and solve for x. I'm going to set this factor equal to 0 and solve for x. And that's going to give me, let's see, x equals 4. And if you wanted to check that, you could go back up here and say, okay, let x equal negative 4. So that's negative 4 squared minus 16 equals 0. That is 16 minus 16 equals 0, and that checks out. That is a valid solution. I could do the same thing for 4. So x equals negative 4. I could say x equals 4. And that's going to give me 4 squared minus 16 equals 0. 16 minus 16 does equal 0. So there are two solutions here, and I was able to find those using factoring and the zero product rule. So trying this out, first I'm just asked to factor. And recall that the first thing you want to do is factor out any greatest common factor, because that's going to make whatever's left much easier to work with. And I see that I have a common factor of 4, a greatest common factor of 4. So this factors into 4 times x squared minus x minus 6. Now, all I have here is a general trinomial. So I want to think about what I have, and I want to make sure that I bring my 4 along with me, because that's part of the solution. Okay, I have a negative sign here. And the only way you're going to end up with that is if one of these is positive and one is negative. Now I'm going to think about what my factors of 6 are. I have 1 and 6 and 2 and 3. I need factors that sum to a middle term of negative 1, and that's not a very large number, so I'm going to look for factors that are close together. I'm going to try these first. Now, one is negative and the other's positive. Since this is negative, I'm going to look for making the larger number negative. So let me try, if I have negative 3 plus 2, that equals negative 1, and that is the middle, that gives me the middle coefficient. The coefficient of that middle term. So, this is what I've got. And I can always check that by using FOIL to go back and multiply these out, and then I would have to multiply the 4 back into it. But this is factored, so I first factored out the GCF, and then I saw I can take it farther because this is not factored out all the way. It's a general trinomial that factors into x plus 2, x minus 3 times that greatest common factor of 4. Okay, now we're asked to actually solve, and this is 3x squared equals 27. Before you can solve a quadratic equation, you need to put it in standard form. recall that standard form is ax squared plus bx plus c equals 0. So I have 3x squared equals 27. To put this in standard form, I'm going to subtract 27 from both sides. And I have an ax squared term. B must be 0 because there's no x term. And then I have a c of negative 27. Okay, so I'm going to solve by factoring. I have this in standard form. Now I'm going to factor out the GCF. And the GCF is 3. So I'm going to pull that out. Now, I'm looking at this, and I see what I have is something in the form of a squared minus b squared, which is the difference of two squares. So the difference of two squares, always make sure you bring this GCF down. Don't leave it behind. So x minus 3, x plus 3 equals 0. So now I'm going to use the zero product property to find my solutions, or zero product rule. And the zero product rule says if a times b equals 0, then a equals 0 or b equals 0. Or they both have to be 0. Okay, so first I'm going to have 3 times x minus 3 equals 0. And if I divide 0 divided by 3, I'm just going to get x minus 3 equals 0, or x equals 3. So that's one solution. The other solution is going to be x plus 3 equals 0, using the zero product rule. And that tells me that x equals negative 3. So my two solutions are that x equals 3 and x equals negative 3. These are my two solutions for this quadratic equation. Okay. And I found that just by factoring. X equals 3, x equals negative 3, and I made my factoring a lot easier by first pulling out the GCF. Okay, again, solve by factoring, and we have another situation where it's not in standard form. So I want to put it in standard form, which is ax squared plus bx plus c equals 0. All right, that is going to give me 4x squared minus 24x plus 36 equals 0, just subtracting 24x from both sides. This is another situation where I have a greatest common factor. So I have a GCF equals 4. Factor that out. Pull that out. That's 4 times x squared minus 6x plus 9 equals 0. Again, I have something much easier to work with since I pulled that out. So figuring out what, how to work with this, I'm going to go ahead and factor this out because it's not all the way factored. And here I have x minus 3 and times x minus 3. And it's actually a perfect square trinomial. It's just, this is really just x minus 3 squared. Okay, so this is a perfect square trinomial because you have x squared, and then I would have, just to check this using FOIL, I would have x squared minus 3x plus 9. So I know I did that correctly. Now I'm going to use the zero product rule, which tells me that if one of these is equal, then they are both. If one of these is equal to 0, then the entire thing is equal to 0. So I can use that to find a solution. Now you can just go ahead and divide both sides by 4, in which case this will move over to here, and that just stays 0. So really I just need to work with this and this. X minus 3 equals 0, and this is the same thing. X minus 3 equals 0. So actually when I figure this out, I just get the same thing for both. and it's x equals 3. So I only have one solution, or one real root in this case. So x equals 3. And again, put it in standard form, factor out the greatest common factor, complete your factoring, and then use the zero product rule to determine that there is one real solution, and that is that x equals 3. Okay, again, solve by factoring. This is already in standard form. However, I have to get rid of this greatest common factor, which is 2. So pulling that out to get 2x squared plus 5x minus 12. When the leading coefficient is not 1, the factoring is a bit more difficult. So let's move over here and work on this. When the leading coefficient is 2, I'm going to have something in this form. And I have a negative here, so I also know that one of these is going to be a positive and one is going to be a negative. But I don't actually know which one yet. But I know I'm going to have plus minus, or I'm going to have this. Okay, let's look at some factors of 12. Factors of 12 would be 1 and 12, 2 and 6, and 3 and 4. Now, 5 is not that large of a number, especially when we think about the fact that we're going to have to be also multiplying by 2. So if I go and use something like 6, and it ends up getting multiplied by 2, it's going to be very large. The difference is going to be great. I want factors that are smaller, since the difference between those, even with this 2x thrown in, is only going to be 5x. So I'm going to start with these because they don't have a large difference between them. So I'm going to start out just trying 2x plus 3 times x minus 4 and see what I get. So I'm not worried about the first term. I'm worried about the outer terms added to the inner terms and see if I get the correct middle term. I'm looking for the middle term equal to 5x. So this is going to give me 2x times negative 4, that's negative 8x, plus 3x. That's 5x. So I've got the right idea, but I've actually got the wrong signs here. So I'm going to try reversing the signs because I want this to be this is negative 5x. I want it to be 5x because here I have negative 8x plus 3x is negative 5x. So same idea. Let's try different signs though. Okay. This time I'm making this negative and this positive. So this is going to give me 2x times 4. That's going to give me positive 8x. Negative 3x is 5x. So this is correct. I got the correct middle term. So this is the correct factoring. And this can be a lot of work to factor these, so it's important to go logically. For example, seeing that I don't have a very large term here, especially when I'm dealing with the 2x also, it's going to amplify things, to look for factors that aren't very far apart. Okay, so now I'm back here and I'm solving by factoring. This is going to give me 2x minus 3 times x plus 4 equals 0. Dividing both sides by 2, this 2 is just going to drop out. So when I use the zero product property, I'm going to get 2x minus 3 equals 0. And I'm also going to get x plus 4 equals 0. So I just need to go ahead and solve those to get 2x equals 3, or x equals 3/2. Okay? Here, I just have x plus 4 equals 0, and that's simple. It's x equals negative 4. So I have two solutions. X equals 3/2 and x equals negative 4. I solved this by pulling out the greatest common factor, factoring that out, then factoring this trinomial into this, and using the zero product rule to give me 3/2 for a solution from here, and x equals negative 4 for a solution from here. So thanks for visiting educator.com, and I'll see you next lesson.